Yeah. This is just to facilitate recording. Can you hear me? Am I audible?
Sir?
Am I audible?
Sir, no, sir. It's very breaking. I mean, it's breaking.
Yeah.
Now it is proper.
Yeah. Now.
Yeah.
Now it's
I
proper.
mean, it was breaking. So.
Okay, fine. So last class we started talking about circles.
Yeah.
Correct?
Sir?
Circles.
Yes, sir.
And we had covered the basic form of equation of a circle, that is center radius form.
Yeah.
We had also talked about diameter form. Okay.
Yeah.
Mm.
So today I'm going to begin with, we had also discussed about intercepts made by a circle.
Yeah.
Yeah.
Fine. So now I'm going to start my discussion with intersection of a line and a circle. So how does a line and a circle interact?
I mean, any line that, that it can be a tangent.
Yeah.
It can be
Or
an
a secant.
This concept is there for your AL as well. ASCL curriculum.
Yeah, yes, sir. We have done this.
Yeah.
So let's
Sir,
see.
Arashi is not coming.
No, she's busy with the exams.
Even I have. So math got over.
How
I
was
mean,
it?
I had. It was easy, sir.
Okay.
I did well.
Okay.
I mean, I don't know. It was easy. I mean, it was only the reptile functions. So.
Okay, so when a line y equal to mx plus c, let me take a very simple case of a circle also, x square plus y square is equal to a square. Okay.
Yeah.
So when this particular line y equal to mx plus c interacts with this circle, it can interact in three ways. As you can see, A, B, C are the three modes of interaction. A is the interaction mode where it is not even touching the circle. B is an interaction mode where it is touching it, and C is a interaction mode where it is a secant line to the circle. Okay. Now I want to find out the condition for this circle and this line to interact in these following three ways. Okay, how will I find this out? Now there are two ways of finding the condition. Let's say I want to find out the condition for A to happen. In A to happen, simple geometry says that the distance of the center, which is origin in this case, from the given line should be greater than the radius.
Yeah.
Correct?
Yeah.
Now, we had already discussed what is the distance of a point from a given line. Let's say x1, y1 is a point, and this is the line. What is the distance? Mod by under root of a square plus b square. This
So,
formula,
wasn't this for? Oh yeah, yeah. Because
Yeah.
yeah.
this formula gives the distance between a point and a
Yeah.
line. Correct? So,
Yeah.
the distance of origin from this line, first of all, this line I would write it as a general form like this. General form is a form where you bring everything to one side and put 0 on the other. So now x1, y1 is 0, 0. And this is your ax plus by plus c equal to 0 line. So when you put, the distance is going to be 0 minus c mod by under root of 1 plus m square. Can I say this distance must be greater than the radius of the circle?
Yeah.
For situation A to happen, which means mod c by under root of 1 plus m square should be greater than a. That means mod c is greater than a under root 1 plus m square, which means c square is greater than a square 1 plus m square. So this is the condition that we need to remember in those cases where the circle and the line, they do not even touch each other. So without wasting of much time, can I say situation number B would be where your c square will be equal to a square 1 plus m square?
Yeah.
Okay. This condition is called COT, condition of tangency.
Okay.
Okay. And situation number C is where your C square will be less than A square 1 plus M square.
Yeah.
Yes or no? Okay.
Yeah.
Based on this, let's have a quick question. Hope you have noted down these three conditions A, B, and
Yes,
C.
one second.
Yeah.
Done?
Yeah.
So 1 second. Yes, sir.
Question is, find the point of intersection of the line. Find the points of intersection of the line 2x plus 3y is equal to 18 and x square plus y square is equal to 25.
So what we usually do is take it in terms of y, like the linear equation, and then substitute it in the circle equation.
Okay. Yeah, that's what you have to do.
That's all, no?
Yeah. This was precisely the other method that I was talking about for finding the condition of tangency. If you go back to the previous slide, this is an important method, that's why I'm discussing it. The alternate method of doing it is, let's say I don't want to use the geometry. That means I don't want to use the fact that distance of the center from the line is greater or equal or less than the radius. Let's say...
Sir, it's not clear.
Hello?
Yeah.
Yeah. Let's say...
Yes.
If the line interacts with the circle, okay, then can I form a quadratic equation in terms of x or y? That depends upon you. Okay, by using these two equations, that's what I think, Shreyas, you were talking about.
Yeah.
So you replace your y with mx plus c.
Yeah.
When you simplify this, you get something like this. Now this quadratic, if at all this line is cutting the circle, it must have real, if it is cutting the circle, then this quadratic must have real and distinct roots.
Yeah.
Okay. If it is touching the circle, it must have real and equal roots.
Yeah.
And if it is not even touching,
then it's not real roots.
Touching, then it has non-real roots.
Yeah.
Okay. So let's say I want to find out the condition for touching. So b square should be equal to 4ac, right?
Yes.
Yeah.
B in this case will be, b square will be this, equal to 4.
Yeah.
A is 1 plus m square. C here is c square minus a square. Okay, so 4 and 4 gets cancelled. If you expand this, it gives you m square c square is equal to c square minus a square plus m square c square minus a square m square. This and this gets cancelled. So take c square on the other side. So c square is equal to a square 1 plus m square. This is what we had derived earlier also. This here, c square is equal to a square 1 plus
Yeah.
Now precisely the same method you are going to use to find out the point of intersection in this case. So I'm sure you would have converted y as 18 minus 2x by 3.
Yes.
Okay.
Yeah.
So when you substitute it, it becomes
Whole
okay.
square is equal to 25.
Multiply throughout with 9, so 9x square plus this will become, you can take a 2 square out, 4, 9 minus x the whole square is 225. 25 into 9 is 225.
Yeah.
Okay, let us expand this. So 9 plus this will become 13x square, and here I'll get 1870 minus 72x, and the constant term will be 81 into 4. 81 into 4 is 324. 324 minus 225. 324 minus 225 is 99.
99.
Okay.
Yeah.
Yeah.
Okay. Now, is this factorizable? Let me check.
I don't think so.
So do you want me? Okay.
Wait.
Okay, I can factorize this as
So
minus 39x
Yeah.
and minus 33x.
Oh, okay.
Yeah.
Take 13x common, x minus 3. Take 33 common, x minus 3 equal to 0. So this implies x is
13x
equal to
minus 33.
33 by 13, or it is equal to 3. Okay.
Yeah.
So if x is 33 by 13, what will be y?
So then substitute in that
6
equation.
minus 6 minus 2/3 of 33 by 13. 11.
Oh,
78 minus 22. 56 by 13.
Yeah.
And when you put a 3, it will be 6 minus 2 by 3 into 3. That's going to be 4. So the point of intersection will be 33 by 13, comma.
Hello?
Yeah.
Oh, sorry.
Is that fine?
Yes, sir.
Okay. Next question. Find the length of the intercepts. Find the length of the intercept. Find the length of the intercept. On the straight line, by the circle, question is clear?
yeah.
Yeah.
So this is a circle, and let's say this is the straight line. They're asking you the length of this guy.
Sir, I can't hear you.
I'm not speaking anything.
Yeah, neither can I.
Hello?
Hello? Yes, sir.
Yeah, I'm not speaking anything. I'm saying that you have to find
Oh,
this
okay.
intercept.
Okay.
Any idea how to do it fast?
Yeah, 1 sec.
What is the center of this circle?
The center is mine. Wait,
I didn't do it. I mean, I didn't specifically find that.
yeah, it's 2 and -4.
No.
No,
Center.
no, that is if it's in the form of x minus h whole square plus.
Oh yeah, my bad. Yeah.
See, if the circle is in this form, center is given as,
Yeah,
I'm again
yeah.
repeating the formula, minus g minus f, and radius is under root of g square plus f square minus c. Okay.
Yeah.
So here your 2g is minus 2. So g is minus 1. So minus g is
Yeah.
1, right?
Yeah.
A
Yeah.
simple trick is divide your coefficient of x and y both with minus 2. That is going to be your center.
Oh.
Okay.
Yes. So can I just write that?
What is going to be the radius? G square means 1 square. F square.
So that's root 5.
Minus c is going to be plus 20. So r
Oh,
is
yeah,
going to be
that's
5.
C.
Correct?
Yeah.
What is the perpendicular distance of the line and this point? Use distance formula.
Yeah.
That's what I did. I was doing that.
Okay.
Yes.
So this becomes 4 plus 6 minus 10. Ayo.
Yeah.
It became 0.
Right.
Yeah, it became 0. That means the line is passing through the center only.
Same.
That means yeah.
Yeah, so your intercept will be twice the radius. This is going to be your answer.
Yeah.
Googly questions. Okay.
Yes, sir.
Yes.
Next. For what value of lambda does this line be a tangent to the circle x square plus y square is equal to 25?
So okay.
So find lambda.
So this is so easy.
Is it 5 root 5?
No.
Sir, I'm doing it. 1 second.
Oh, is 5 root 5? I think that should be correct.
Okay.
What is the condition?
C square equals A square into 1 plus M square.
Okay.
Yeah.
Guys, one word of caution here. This formula is not to be used if the equation of the circle is not of this form. If it is of this form,
Yeah.
it should not be used.
Yeah.
This formula is
Yes.
derived only for situations where x square plus y square is equal to a square is the equation of a circle. For such cases, it will not work. Okay. So many
Yeah.
people have seen they apply this formula everywhere. It doesn't work everywhere. It works only when, first of all, line must be given as y equal to mx plus c form. Secondly, your circle equation must look like x square plus y square is equal to a square.
Yeah.
Yeah.
So here your c is lambda square, a square is 25, 1 plus m square is 2 square, which is equal to 5. So lambda square is this into 5. So lambda is plus minus 5 root 5.
Yeah. I took the long way around.
Okay. What is long way around?
No, like I substituted y in this and then quadratic equation.
But that effort we have already put in while deriving it, right?
I mean, d square minus 4ac. Sorry. Yeah.
Okay.
Yeah.
Now we'll talk about equation of tangent in various forms. First is we are going to talk about that case where I'm trying to find out tangent at a given point x1, y1. Okay. And the circle equation is the general form of a circle, which is x square plus y square plus 2gx plus 2fy plus c equal to 0. Okay. And if I'm constructing a tangent at this point, what is the equation of this tangent? Okay. How will I find this out? Any idea?
You can use the fact that like the distance. Wait.
Distance is equal to radius.
So that doesn't give me the equation.
Yeah.
How would I get an equation? By using geometry. Geometry cannot help you to get the equation. Geometry can help you to get dimensions. Coordinate geometry will help you to get equations. Okay. The idea is very simple. What is the center of the circle?
G. Wait, root of f square plus g square minus.
Center. Center is minus g minus f.
Wait, so which one is? Oh yeah, that's the radius. My bad. Yeah.
Yeah.
Okay.
Yeah.
What is the slope of this line? Let me call this line as P. Let me call this line as C. What is the slope of CP? You will say y1 plus f
y1
plus x1 plus g.
Yeah.
So what will be the slope of the tangent then? Because you know the tangent is perpendicular to the radius line.
Yeah.
So it is negative reciprocal of that. Yes.
So I can't hear you.
So I can't hear you either.
See, what I'm trying to say is that tangent line is perpendicular to the radius line. Correct.
So okay.
Correct.
So yeah. Now I can.
My internet connection is not very stable today. I don't know why. Okay. So we know that when.
So 1 second, can I just go get my charger?
No. Yeah, get it.
Yes.
So you know that product of the slope of the tangent and CP line should be -1.
Yeah.
So that means tangent slope should be negative reciprocal of the slope of CP. Okay. Now once you know the tangent, you can use the equation which is called the slope point form. Y minus y1 is equal to minus Okay. Now, if you simplify this, I'm saving your time of simplification. On simplification, this becomes x(x1) plus y(y1) plus gx plus x1 fy plus y1 plus c equal to 0. This becomes your equation of the tangent. Now, there's a very beautiful thing that is happening over here. If you see these two equations together, you'll see some pattern.
Yeah.
Oh.
Do you realize that your x square, that is x square, got replaced with x(x1)?
X1.
Yeah.
Correct?
Yeah.
Your y square got replaced with? Your y square got replaced with?
With y1.
y(y1). If you see, your 2x got replaced with?
X plus x1.
X plus x1. Or in other words,
Yeah.
x got replaced with, sorry, x got replaced with x plus x1 by 2.
Yeah.
Y got replaced with? Okay.
Y plus y. Yeah.
C doesn't undergo any change.
Yeah.
Okay. Now, this is a very important tool in our hands because it actually helps us to find out the equation of tangent drawn to any conic at x1, y1 on that particular conic.
Hello?
Hello?
Yeah.
Can you hear me?
Sir, could you repeat that?
Yeah. The same replacement can now be done for any conic, not only a circle. Let's say your conic is ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equal to 0. Okay. And I want to find out the equation of tangent at a point x1, y1. Okay.
Yeah.
The same replacements can now be done. So this x square will now be replaced with axx1. By square will be replaced with by(y1). Now xy will be replaced with what? Now there's something which I missed out. Let me go back. If at all your conic contains xy term, it will be replaced with xy1 plus x1 y by 2. Please make a note of this.
Okay, yeah.
Okay. So this 2hxy will become hxy1 x1y. 2gx will become gx plus x1. 2fy will become fy plus y1. C remains a c. So this is a much faster way to get the equation of the tangent rather than finding slope and constructing the slope point form, etc., etc., etc.
Yeah.
Okay. So this trick you remember for any conic. It will work for any conic. Is that fine? Let's take a small question on this. Find the equation of tangent to the circle x square plus y square minus 2 x equal to 0 at the point 3 by 2 comma root 3 by 2. Let me check. This point lies 9 by 4, 3 by 4 minus 3. Oh yeah, it lies. Fast. You should give me the answer within 10 seconds.
Yeah. Within
10 seconds.
Oh. Yeah, so then it's just 3 by 2x plus root 3 by 2. Wait, no.
3 by 2x. Come on.
Oh, yeah. Okay.
Yeah.
Plus?
Plus root 3 by 2y. Plus
minus
x plus 3 by 2.
I've written plus.
Wait, minus
x plus x1 by 2, right? This x got replaced with x plus x1 by 2.
Yeah.
2 gone. So 3x by 2 plus root 3y by 2 minus x minus 3 by 2 equal to 0.
Yeah.
So that gives you x by 2 plus root 3y by 2 minus 3 by 2 equal to 0. So x plus root 3y minus 3 equal to 0. That's your answer. Okay?
Yes.
Next concept. Same, we were talking about different forms of the equation of a tangent, right? Now let's say, did I talk earlier about the parametric form of the equation of a circle? No?
Yeah, I think you did. Yeah, you did.
Parametric form? No, I don't think so. I've done.
Yeah,
I think you said we have to start this or something.
Oh, okay. So I'll just take a minute to discuss this. See, when you write the equation of a circle like this, okay, this form is called a Cartesian form, where you're directly relating the two variables with each other. But instead of writing this, if you write the same thing as x equal to a cos theta and y equal to a sin theta, where theta is some parameter. What is a parameter? Parameter is something which keeps on changing, correct?
Yeah.
And as it changes, it changes your x and y coordinates. But x and y will always be related by this relation. Okay. So if you eliminate your theta from this, then you'll end up getting this equation. Okay. So both are the same thing, but this is called the parametric form of the equation of a circle, and that is called the Cartesian form. Okay. So now people ask me, why do we need a parametric form when we already have a Cartesian form? What do they use? See, parametric form uses, it enables us to choose a point on the curve without unnecessarily involving lot of variables. What many people do is, if they're asked to choose a point on a circle, let's say this is my circle, okay, x square plus y square is equal to 4. Okay, if I ask somebody to choose a point on this circle, how would you normally choose? How would you normally choose? Shreyas? How would you normally choose a point?
You would look at the. No, you would look at the.
You will choose x1, y1, right? Like this.
Yeah.
So unnecessary two variables you are putting into the system.
Yeah.
Instead of this, if I choose the point as 2 cos theta, comma 2 sin theta, then I only need one variable, which is theta. Working with one variable is much easier vis-a-vis working with two variables, right? So the main role of parametric form is it enables us to choose a point on that curve without unnecessarily involving many unknowns. Get the point?
Yeah.
Okay.
So 1 second, I'll just write this down.
Now, just a question for you all. Had the equation of the circle been this, x minus 2 whole square plus y minus 3 whole square is equal to 4, right? In this case, your parametric form was x is equal to 2 cos theta and y is equal to 2 sin theta, right? Can you suggest the parametric form for this guy? What should I write x and what should I write y?
Shouldn't it be the same thing?
Same thing. How will it be same thing, Dhruv? If you do x minus 2 whole square, y minus 3 whole square on this terms, will it give you a 4? If you eliminate your theta, will you get the same equation? That's what is my concern. No, right?
No.
So how would you do this?
So x minus 2 equal to a cos theta. In this case, that will be
so x
4.
minus 2. So you're on the right track, Shreyas. X minus 2 is equal to 2 cos theta. So can I say x will be 2 plus 2 cos theta?
Yeah.
And y will be 3 plus 2 sin theta. Okay.
Yes.
So now coming back to our requirement, let's say I give you a circle whose equation is x square plus y square is equal to a square. Okay. And I give you a point here, a cos theta, comma, a sin theta. And I ask you, write down the equation of a tangent drawn at this point.
So it will be ax cos theta.
Yeah, nothing will change. Everything will remain the same as what we did for the general case. That means replace your x square with xx1, y square with yy1. And constant will remain a constant, right? A square will remain a square. Now x1 is nothing but a cos theta. So y1 is nothing but a sin theta. And drop the factor of a from everywhere. This becomes the equation of a tangent to this circle. And this is actually called as the parametric form of the equation of a tangent. Parametric form of a tangent. By the way, this form is called, where was it? I'll go back. Yeah, this form is called the point form. It's in the previous board. Yeah, this form is called as the point form of the equation of a tangent. Okay.
Yeah.
Any questions here?
No.
Clear? Okay. Let's take questions. Yeah. Question is, if Lx plus my equal to 1 touches x square plus y square is equal to a square. Okay.
Yep.
Then L comma M lies on option A, x square plus y square is equal to a square itself. Option B, x square plus y square is equal to 1 by a square. Option C, x square plus y square is equal to 2 by a square. And option D, x square plus y square is equal to 2a square. What is the meaning that L comma M lies on? It means L, M, N are varying, right?
Yeah.
So they are varying, but they are varying in such a way that this line continues to touch the circle. Getting my point? So L,
Yeah.
M, N,
Yeah.
L and M are parameters, but these parameters are in such a way linked that the line resulting out of Lx plus My equal to 1 always touches this circle. Correct?
Yeah.
Yeah.
So then they're asking L comma M satisfies which of the following equations?
So then it should be A then, right?
Yeah.
No.
Because it's always
No,
satisfying.
line is touching. L comma M lies on what? L comma
Okay,
M are
yeah,
these
yeah.
numbers. See, it's very simple. You just have to use the fact that the distance of this line from the center of the circle is the radius. Isn't it?
Yeah.
So what is the distance? What is the radius? Radius is going to be A, and that's going to be 1 by under root of L square plus M square.
Yeah.
Yeah.
Which means under root of L square plus M square is equal to 1 by A. That means L square plus M square is 1 by A square. So if you treat this as your X coordinate and this as your Y coordinate, it implies this L and M will satisfy this equation, which is your option number B.
Yeah.
Getting the point?
Yes, sir.
Yeah.
Okay. Next is the concept of equation of normal to a circle. What is the meaning of normal?
Perpendicular to.
Yeah.
Perpendicular to the curve. Is it perpendicular to the curve?
Yeah. Right.
No, it's perpendicular to the tangent at the curve at that point.
Yeah.
So let's say if you draw a tangent, and normal would be perpendicular to the tangent. Okay, so this line, let me draw it in different color. This green line, that would be your normal. Okay. Now my question to you is, if this is your circle and this point is x1, y1. Okay, what is the equation of the normal line?
So we had this in math. I think.
Okay.
Oh no, but then that used differentiation. So.
It's simple. You know that a normal to the tangent will have to pass through the center.
Yeah.
Correct.
Yeah.
So now you have been given 2 points x1, y1 and 0, 0. What is the equation? What is the equation of the line through it? Slope will be what?
Yeah.
Slope will
So
be
then
y1.
it will just be. So it will be y minus y1 upon x minus x1 equals.
Or take it 0. No, why you want to take y1?
Oh yeah.
Okay. So your answer will be y by y1 is equal to x by x1. Done. Okay.
Yeah.
Just remember one fact: in case of a circle, the normal at any point will pass through the center of the circle.
Yeah.
A quick question: find the equation of a normal to the circle. Find the equation of the normal to the circle. This at point 5, 6. Guys, I'll just be back. I'll have some water. Okay.
Yes.
Yes, sir. Yeah, Dhruv. Yeah, I mean, can you send me the notes on what you did in chemistry the other day?
Yeah, okay.
Thank you.
Done?
Yeah, I think so.
What's the answer?
I got y equals 7x minus 35 upon 2.5 plus 6. I don't know if that's.
So, one
Shreyas?
sec.
So what is the center?
The center is 2.5 comma minus 1.
Yeah. So what is the equation of a line connecting these two? First of all, the slope of the normal would be 6 plus 1, 7.
Yeah.
And 5 minus 5 by 2 is 5 by 2. So that's 14 by 5. So you can write the equation as y minus 6 is equal to 14 by 5, x minus 5. That's 5y minus 30 is equal to 14x minus 70. Okay. So 14x minus 5y minus 40 equal to 0. 14x. That's what the book also says.
Yeah.
Okay, now I'll give you some thought-provoking questions since you have learned this concept. Find the equation of a tangent, or find the equation of the tangents. Find the equations of the tangents to the circle drawn from the point 1 comma 4. Read the question carefully. It is drawn from the point, not on the point.
Yeah.
That means this point is external to the circle.
Yeah.
Yeah. Sir, can I quickly have, something? to eat. Like I'm.
Sure.
Sorry, sir.
Okay, no problem. Dhruv, any idea?
Yeah, I think I got one equation. Not sure. So I got one of the equations as x plus 4y equals 16.
What is that?
X plus 4y equals 16. One of the equations.
No, there is no such answer like that.
Oh, yeah.
Okay, see here, the idea is, you know that if this line y equal to mx plus c is a tangent to x square plus y square is equal to a square, the condition of tangency is
C square equals a square into 1 plus m. Yeah.
okay. So let's say I do the opposite over here and I say c is equal to plus minus a under root 1 plus m square. Okay. Take any one of them. You don't have to take both of them. Let's say I take a plus 1 plus a. Okay. So can I replace this equation with y equal to mx, and instead of a c I can write it as a 1 plus m square.
Yeah.
By the way, a here is 4, so I can write it as this. Correct? Now,
Yeah.
such a line must be satisfied by the point 1 comma 4. So 1 comma 4 will satisfy this point line.
Yeah.
So 4 is equal to m plus 4 under root 1 plus m square. Correct?
Yeah.
This leads to an expression like this. And if I square both the sides, (16 m square minus 8m), this will be 16 1 plus m square. This leads to a quadratic in m, correct?
Yeah.
This and this gets cancelled. So it ends up giving you 15m square is equal to minus 8m, which implies there are two values of m. One is m is 0 and other is m is minus 15 upon 8. Sorry, opposite, minus 8 upon 15.
Yeah.
Okay. So the equation of the two tangents is y minus, what is the point? 1 comma 4, right?
Yeah.
So y minus 4 is equal to 0, x minus 1, which is nothing but y equal to 4 line. And y minus 4 is equal to minus 8 by 15 x minus 1, which is going to give you 15y minus 60 is equal to minus 8x plus 8. So the other line is 15y plus 8x is equal to 68. These are the two answers.
Okay.
Okay, sir.
Okay. Now,
Yeah.
next question again. Let's see. Find the length of the tangents. Find the length of the tangents from the point 3 comma minus 4 to the circle 2x square 2y square minus 7x minus 9y minus 13 equal to 0. Okay. Before we solve this, I would like to take a generic case. Let's say I give you a circle x square plus y square plus 2gx plus 2fy plus c equal to 0. Okay. And I give you a point here x1, y1. And I say that I'm drawing two tangents from this point onto this circle. First of all, are you convinced that these two tangents would be of equal length?
Yeah.
Okay.
Yeah.
Secondly, are you convinced that this is going to form a right angle triangle like this?
Yeah.
Correct. Now this point is known to you as the center of the circle, and this length is nothing but the radius of the circle, isn't it? And let's say this is the length of the tangent. Let me call it as L. Okay. So can I say L square plus R square will be equal to the square of the distance between the point P and the center C, that is PC square?
Yeah.
Correct. So L is not known, so let it be L square. Can I say R square is G square plus F square minus C? PC square is x1 plus g the whole square, y1 plus f the whole square.
Yeah.
Correct?
Yeah.
If you expand this, you will get 2gx1 plus g square, y1 square plus 2fy1 plus f square, and this is L square g square plus f square minus c. I think you will lose out a g square f square on both the sides. Oh shit. Yeah. G square, f square gone. Okay. Bring this c on the other side. So L square is x1 square, y1 square. Now you'll be surprised to see the resultant expression. So what is L?
Oh.
What is L?
Yeah. So L is the equation of the circle.
Basically, L is nothing but in the equation of the circle, you have put the value of x1 and y1 as the given point and taken the root of the entire answer. Getting my point?
Yeah.
So here, first of all, convert it to the form that basically you can use. So basically divide by 2.
Yeah.
Correct? Now, if you want to find a length of the tangent down from this point, put this in place of x and y, and whatever put here, just forget this 0 term. Okay. Whatever number you get, take the under root of that. That will be your answer.
Yeah.
Okay, so let me just do it quickly. The point is 3 comma minus 4. So 3 square 4 square is going to be 25 minus 21 by 2, and this will give you plus 18 minus 13 by 2. Whatever is this answer, take the root of it. Okay, so that's going to be 43 minus 34 by 2 is 17 under root. That's going to be under root of 26.
Okay. Got
Correct?
Yep.
Okay. Next concept that we are going to talk about is the equation of the chord of contact. Now, what is the chord of contact? If from an external point, from the external point I draw two tangents, okay, the line connecting the point of contact, this red line is called chord of contact. Okay. Now my question here to both of you is, let's say this is the point x1 y1 and this is the circle x square plus y square is equal to a square. Okay, prove that the equation of the chord of contact, prove that the equation of the chord of contact is x1 plus y1 is equal to a square. Now this must surprise you, because wasn't this the equation of the tangent also?
Yeah.
But this time x1 y1 is not on the circle, it is outside the circle. So even if the same equation is used, it doesn't mean you're getting the tangent, because x1 y1 is external to the circle. Can you prove this? Any idea how to prove it?
No.
Okay. See, let's say this proof may surprise you also, because it's slightly tricky. Let's say this point is x dash y dash. and this point is x double dash, y double dash, let's say. Okay.
Okay.
Yeah.
Now, can I say this line, let me call it as PT1. Can I say PT1 is like a tangent drawn to x dash, y dash?
Yeah.
So can I say its equation should be x dash, y dash is equal to a square? Okay. And
Yeah.
x1, y1 will satisfy this. So can I say x1, x dash, y1, y dash is equal to a square would be true. So let's call it as 1. In the same way, can I say x1, x double dash, y1, y double dash will be a square. Let's call it as 2. Okay. Now, if I ask you that there is a line which passes through x1 x dash y dash and x double dash y double dash, what is that line? Looking at 1 and 2, you can say, hey, x1 x dash y dash and x double dash y double dash seem to satisfy this equation. x1 x, y1 y equal to a square, right?
Yeah.
Yeah.
So this becomes your answer. This is your chord of contact. That's what we wanted to prove.
Okay.
Oh, yeah.
Okay.
It's a very funny proof, actually.
Yeah.
Okay.
Yeah.
Fine. Now, let me give you a small question. So let's say we have 3 concentric circles. Okay. The inner circle. Hello?
Hello.
Yeah.
Okay.
Yes.
The inner circle has the, let me call this as circle 1, circle 2, circle 3. Circle 1 equation is x square plus y square is equal to c square. Circle 2 equation is x square plus y square is equal to b square. And circle 3 equation is x square plus y square is equal to c square. Okay.
Okay.
Now listen to the question very carefully. The chord of contact of tangents drawn from a point on the outer circle. Let's say this is a point and you draw a chord of contact. Okay, this is the chord of contact. Okay, so if the chord of contact drawn from a point on the outer circle to the mid circle touches the innermost circle, then A, B, C are in option A, arithmetic progression, option B, geometric progression, option C, harmonic progression, of option D, none of the above. You know harmonic progression?
Oh,
Huh?
no.
No, sir.
You know arithmetic progression, right?
Yeah.
Yeah.
In arithmetic progression, if your A, B, C are in arithmetic progression, then we say that 2B is equal to A plus C. If they're in geometric progression, if A, B, C are in geometric progression, then we say B square is equal to AC. If A, B, C are in harmonic progression, then we say 2B is equal to, sorry, B is equal to 2AC by A plus C.
Hello.
Hello. Hello.
Yes, sir. Yeah. Accent comes out sometimes.
Hello. That is called British accent.
But I'm not British, sir. I don't know why it comes out.
So from the outer circle, that is the third circle, you are drawing chord of contact to the second, which happens to be a tangent to the first.
Yeah.
So, oh, by the way, my bad. This is a squared. Any idea?
No,
1 second.
not really.
So can you do it?
I can do it. See, first of all, if I say there's a point on the outer circle and you're drawing a tangent to the chord of contact to the inner circle. Correct?
Yeah.
Mm.
Can you choose a point on the outermost circle? That is the third circle. Remember, I told you if you want to choose a point, you should choose it as in a parametric form. Correct?
Yeah.
Yeah.
So what point? How will you choose a point there? Tell me.
So then that would be a cos theta.
Correct. Correct. So you can choose this point as a cos theta, comma a sin theta, right? Now treat this in your mind as your x1, y1. So what is the equation of a chord of contact? Just now we discussed the equation x
Yeah,
x1.
so that's x x1. So that would be ax cos theta plus ay sin
x
theta.
x1 will be a cos theta. Then y1. y1 will be ay sin theta is equal to b square, correct?
Yeah.
Okay. Now this line is a tangent to the innermost circle, which is x square plus y square is equal to c square. Correct? What is the condition of tangency?
So
Just now recall
yeah.
this formula: y equal to mx plus c is tangent to x square plus y square is equal to a square. What is the condition? C square is equal to a square 1 plus m square.
C square equals
Okay. Now
a square.
what is c here?
Yeah.
Who is playing the role of c here? Who's playing the role of c here? Can I say it is b square by a sin theta?
Wait, yeah.
Yeah.
Be convinced first. Sure.
Wait, I'm not sure. Wait, how?
Just divide throughout with a sin theta. You write it like this. Let me write it here. Ay sin theta is equal to b square minus ax cos theta. Divide by a sin theta throughout. So this will become x cot theta plus b square by a sin theta. Correct?
Yeah.
Yeah.
Correct. So m is minus cos theta,
Okay, yeah, got
cot
it.
theta, and c is this term. Okay, so c square is equal to a square. Who's playing the role of a square? Actually, it is played by c square.
Yeah.
1 plus m square. M square is cot square theta. Correct?
Yeah.
Yeah.
By the way, c square I have not done. This is just c. This is c square. So b to the power 4 is a square sine square theta. And 1 plus cot square theta is cosec square theta. Cosec square is 1 by sine square. Sine square gone. That means b to the power 4 is a square c square. That means b square is equal to ac. That means they are in. See here. They are
that means they're in GP.
They are in GP. Got the point?
Yeah.
Yes, sir.
Okay. Next concept that we are going to take up is the concept of chord bisected at a given point. So if I give you a circle whose equation is x square plus y square is equal to a square, and I give you there is a chord whose midpoint is x1, y1. Okay. Find the equation of this chord, or prove that the equation of this chord is given by x1 plus y1 is equal to x1 square y1 square. Any idea?
Yeah, once. No, I don't know.
Okay. See, if I just ask you this question, that if this is the midpoint, can I say a line connecting the center to this point should be perpendicular to this line?
Yeah.
Correct?
Yeah.
Okay. So what is the slope of this line? Can I say it's y1 by x1? So slope
Yeah.
of this line should be minus x1 by y1.
Yeah.
Let's say
I got till there. I don't know after that.
You got a slope and you know the point. Slope point form.
Oh yeah. Okay,
Y minus y1 is equal to minus x1 by y1, x minus x1. Cross multiply. Y1 minus y1 square is minus x1 plus x1 square. Bring this term to this side. Bring this term to the other side.
Yeah.
So x1 plus y1 is equal to x1 square plus y1 square. Done. Got it?
Yeah.
Yes.
Question on this, let's take. Are your exams going on, Aryan? Sorry, Dhruv?
Yes, sir.
Your exam is also going on?
Yeah. Yes, sir.
So Monday, which exam you have?
I have chemistry, sir.
Okay.
So I have physics. But then what we're doing in class tomorrow is completely different from what we have. So I don't know. So these few weeks will be a bit
Tough.
iffy.
Okay. Let's take a question on this. The midpoints of chords of the circle which subtend, this is 4, which subtend (90°) at 1, 0 is option A. Option B. Option C. Option D. First of all, you understood the question?
Yeah.
Yeah.
So there's a variable chord, and this chord moves in such a way that that chord subtends always 90° at 1, 0. So let me draw this circle. So this is this is 1, 0. So let's say this is my chord. The angle subtended here by this chord is 90° always. So I have to find what path will the midpoint take. So will the path be this, or this? Any idea?
One sec.
Should I help you?
Yes, sir.
Okay. Let's say I call this point as A, I call this point as B, and I call this point as N, and I call this point as P. Okay.
Yeah.
Yeah.
First of all, do you agree that NA will be equal to NB will be equal to NP?
Wait, so why is it equal to NP?
Okay, very good question. If you draw a circle passing through all these 3 points, do you see that NP, NA, and NB would be like the radii of that circle?
Okay, yeah.
Okay. I think this is something which Dheeraj sir also did with you.
Sir?
This length will be equal to this length will be equal to this length. No?
I don't think he did.
No.
Okay. So NA square will be equal to NB square. Okay, let me call this as H comma K point. Okay. And this should be equal to H minus 1 the whole square, K minus 0 the whole square.
Yeah.
I just square all of them. Correct. Okay. Achha. One more thing is, if I drop origin from this will be 90 degrees.
Yeah.
Correct, no?
Yeah.
And let me connect this point also. Okay.
Yeah.
Okay. Now can I say OB square is ON square plus NB square?
Yeah.
Yeah.
Okay. OB square will be what? What is OB square?
Oh, the radius.
The radius.
Yeah.
That's A square. That's 4
Yeah.
actually. Correct.
Yeah.
What is ON square? ON square is H square plus K square.
Yeah.
And what is NB square? NB square is H minus 1 the whole square, K minus 0 the whole square. We just figured out what is NB square here.
Yeah.
Correct.
Mm.
Okay. If you expand this, you get 4 square is H square plus K square. This will be H square minus 2H plus 1 plus K square. If you group up all the terms, it'll give you 2 times H square plus K square minus 2H plus 1. Correct.
Yeah.
So bringing all the terms to one side, so 2H square plus K square minus 2H minus 3 is equal to 0. Just replace your H with X, K with Y. So your desired answer will be 2x square plus y square minus 2x minus 3 equal to 0. Is there any option which matches with this? Option number C.
C. Yeah.
Getting it?
Yes, sir. Yes.
Okay. Next concept that we are going to take is the concept of pair of tangents. A little while ago, we were talking about chord of contact, right? What is chord of contact? Chord of contact is basically the line connecting the
tangent, the
point of contact
of intersection of the
So okay. So let's say I have a circle. Okay. X square plus y square is equal to a square, and I give you that there is a point x1, y1 from which you're drawing these two tangents, pt1 and pt2. Okay.
Yeah.
Can you find out both these equations? In fact, can you find out the combined equation of pt1 and pt2? That means, can you write it as a pair of straight lines? Shares, were you there when we did pair of straight lines?
So when was this? Yeah, I don't remember.
Okay, fine. So let me give you a question. Let me directly jump to a question. You'll understand better by a question.
Yes, sir.
Question is, prove that the equation of the pair of tangents drawn from a point 3, 2 to the circle x square plus y square plus 4x plus 6y plus 8 equal to 0 is 2x square plus 2y square minus 5xy minus 2x plus 7y minus 4 equal to 0. Basically, it was a objective question, but I gave you the answer so that you can prove it. Now, pair of tangents, just to tell Shreyas, let's say you end up getting the equation of this as a1x b1y plus c1 equal to 0, correct?
Yeah.
And this as a2x plus b2y plus c2 equal to 0. So if somebody says what is the equation of this pair, you just have to multiply them. That's it.
Okay. Both the equations.
Both equations, you just have to multiply them.
Okay.
Just do it. Any idea?
No.
Same approach. I think I gave you a question on finding the tangents, right? Same approach you have to take.
Oh, yeah.
Yeah, but here the problem is your circle is not the standard form, it is the general form actually.
Yeah.
Yeah, so some problem will arise over here. So direct formula cannot be used, but still it is solvable. So what is the center of this circle?
Oh, -2 and -3.
Minus 2,
Yes.
minus
2,
3.
minus.
Okay, and let's say this line has a slope of m. This line has a slope of m. Okay, and this point there is 3, 2. Correct? I know there are two such lines, but I'm just drawing one for the sake of reference. Okay. Yeah, so you're right. The center of this circle is -2, -3. Correct?
Yeah.
Now, if I say the slope of this line is m, can I say the equation of this line will be y -2 is equal to mx -3?
Yeah.
Correct? Can I say the distance of -2 from -3 will be equal to the radius of this circle? And what is the radius?
The radius is, yeah.
√5. Correct? No.
Yeah.
So if you write this properly, it is y minus mx plus 3m minus 2 equal to 0. So from this point, if you draw, it will be -3 plus 2m plus 3m minus 2 mod by under root of 1 plus m square. This should be equal to √5.
Yeah.
Correct? Can I write this as 5m minus 5 mod is √5 under root 1 plus m square? Can I
Yeah.
square both the sides?
Mm.
So 25m minus, sorry, plus 25 minus 50m is equal to 5m square plus 5.
Yeah. So 25m square.
Okay, so that means 20m square minus 50m plus 20 equal to 0.
Yeah.
Drop 0, 0, zeros from everywhere. Is it factorizable? Yes.
Yeah.
Minus m. Take m common. Take -2 common. So m could be 2 or m could be half. Okay. So your your desired lines would be, come back over here. If you put m is equal to 2, the equation will be y minus 2x plus 4 equal to 0, if I'm not wrong.
Yeah.
Okay. And when you put a half, what do you get? Y minus x by 2 plus 3 by 2 minus 2 equal to 0. Multiply throughout with 2, so 2y minus x minus 1 equal to 0. Correct?
Yeah.
So now the combined equation of these two lines would be what? Y minus
2y
2x
square.
minus 4 into 2y minus x minus 1 equal to 0. Just expand it.
Yeah.
Expansion will give you 2x square. Let me just simultaneously compare. 2x square, 2x square. Yeah. 2x square we got here. Then you'll have 2y and y is going to be 2y square. So this term is also okay. Xy term will be minus xy, and this is minus 4xy. So minus 5xy.
Yeah.
Minus x into 4, that is minus 4x, and plus 2x, which is minus 2x. Okay. Y term will be minus y plus 8y, 7y. And 4 into minus 1, minus 4. Okay. So this is the desired answer. Next concept that we are going to take up is the concept of director circle. Now, what is a director circle? Let me define it first. Director circle is the locus of points from which the tangents drawn to a given circle are perpendicular. Okay. So what do I mean to say is, let's say this is your given circle. Now such points, let's say there's a point here, h comma k. If you draw tangents, these two tangents will be at 90 degree to each other. So all such points from where you can draw tangents which will be at 90 degree to this circle, the locus of all those points will create another circle which we call as the director circle. Okay. Now a question for both of you. Let's say the equation of this inner circle.
So could you repeat the directed circle thing? The internet, there was a.
See, director circle is the locus of all such points, from which tangents drawn to a given circle are perpendicular.
Okay.
Okay, yeah.
Now prove that the equation of this director circle for this circle would be x square plus y square is equal to 2a square. Done? There are 3 ways to do it. Any one of the way you can do it. Okay, let me help you out with this. First is I will use geometry. Can I say that if this is a circle and if I connect the center over here, this will be 45 degrees each? Correct?
Yeah.
Yeah.
Okay, now if this is A, this is 45 degrees and this is 90. What is this length? Let me call it as CP. What is CP length?
Oh, wait. CP would be A upon sine 45, right?
What is A upon sine 45? Root 2
A root 2. Yeah.
A root 2. Okay. Now this circle will have the same, director circle will have the same center, but its radius will be root 2a. So can I say its equation would be?
Okay.
Yeah.
Okay, done. This is your answer.
Yeah.
Which is the same as this. This is one way. Other way would be, let's say I consider the equation of this line to be y equal to mx plus c. Okay. Now, can I say h comma k will satisfy this? So k is equal to mh plus c.
Yeah.
And c is equal to k minus mh. So can I say c square will be a square 1 plus m square if this line has to be a tangent, because this is your condition of tangency?
Yeah.
Correct? That means
Yeah.
k minus mh whole square is equal to a square 1 plus m square. Correct?
Yeah.
So this will give you k square m square h square minus 2 m kh or hk is equal to a square plus a square m square. Now, something very interesting here. This is a quadratic whose roots are m1 and m2, right?
Yeah.
Shreyas, do you agree?
Yes, sir. Sorry, there's some this thing.
And you know that m1 into m2 has to be minus 1. Why? Why?
Because they're perpendicular.
Because yeah.
They're perpendicular. So in any
Yeah.
quadratic, the product of the root is given as c by a, right?
Yeah.
Okay. So c by here would be k square minus a square by h square minus a square, and this should be minus 1.
Yeah.
Yeah.
Which means k square minus a square is a square minus h square. That means h square plus k square is 2a square. Now generalize this. So x square plus y square is equal to 2a square. Done. Proved. Correct?
Yeah.
I'll show you the third way also. You want to copy this down?
Yes, sir. I just did.
1 second, just copy. So yes, sir, done.
Okay. I'll show you a third way. for that third way, I think Shreyas will not be comfortable.
Which third?
Basically, I was trying to use the fact that if a pair of lines represent two such lines where the lines are perpendicular, the coefficient of x square and y square should add up to 0. But I think Shreyas was not in that class, but I'll forward the video to him. Anyways, I will take a quick question on this. Doesn't matter. You don't have to know 500 ways of proving it. One way is sufficient. Question is, find the equation of the director circle. Find the equation of the director circle of x square plus y square minus 2x minus 4y minus 4 equal to 0. Find the equation of the director circle for x square plus y square minus 2x minus 4y minus 4. It may look like a 9, but it's minus 4. Done?
Yeah. X square plus y square minus 2x minus 4y equals 18.
Okay, let's check. See, the one thing that you have to catch up over here is that the center would remain the same. So center for this circle is 1, 2. Radius is 1 square plus 2 square minus of minus 4, which is going to be 3. Okay.
Yeah.
Now remember, the center for this will be the same as the center would remain the same even for the director circle.
Oh, okay, so then wait, yeah.
And radius of the director circle would be nothing but root 2 times 3. Correct?
Yeah.
So its equation will be x minus 1 the whole square, y minus 2 the whole square is equal to 3 root 2 whole square. That's nothing but x square minus 2x plus 1, y square minus 4y plus 4 is equal to 18, which is nothing but x square plus y square minus 2x minus 4y minus 13 equal to 0.
Yes, sir.
I think Dhruv forgot this 1 and 4 terms.
Yeah.
Okay. So guys, we'll end the session over here. Next class when we meet, I'm going to talk about quickly the concept of diameter, the concept of two circles interacting with each other. Okay.
Okay.
Then the concept of family of circles. So that would be the end of the circle chapter. Most of the concepts that we'll be learning from circle, that would be taken forward to your parabola, ellipse, and hyperbola as well. Okay.
Yes, sir. Yeah.
Okay then.
Okay, sir.
Let's call it a day.
Thank you, sir.
Thank you so much.
Sir.
Have a good day.
Thank you.
Bye.